Good day, students. Welcome to part one of the Accuplacer college level math test. We're going to be going over 10 sample questions in this series. Okay. All right. Now let's go ahead and take a look at question number one. It says solve the problem. Um, Use the paper you're given for scratch work. So number one is we have 2 to the 5 halves minus 2 to the 3 over 2. Okay. Now, looking at this question, some people might be tempted to carry out the following procedure. They might say, oh, wait a minute. The fractional exponents have the same denominator. Since we're subtracting, why don't we just go 5 over 2 minus 3 over 2 equals 2 to the 2 over 2, which is 2 to the 1, which is 2. Voila, answer is B. Well, that is absolutely wrong, okay? This procedure I just applied here is if we were dividing, if we had 2 to the 5 over 2 over 2 to the 3 over 2, or if we had 2 to the 5 over 2 divided by 2 to the 3 over 2. Then we'll apply a procedure called, a rule called the quotient property of exponents. That's when you subtract, anytime you're dividing exponents, you subtract the powers. But that's not the case here. This is a difference of exponents, so we cannot use this rule here. Okay. All right. So this is wrong. FYI, this is the wrong procedure. To actually do this problem correctly, there are two different ways we can do it. Okay, I'm gonna do it the elementary way, which is a little bit easy to master, and then the quick way, which is very complicated. Okay, but it's short. So first thing you have to do is, first of all, whenever you're dealing with exponents that have improper fraction as powers, we must write the powers as um, mixed numbers, and then we have to write it in radical form. So the goal is to convert this to radical form, okay? So how do we convert this to radical form? Well, first of all, write the powers as mixed numbers. So we're going to have 2 to the 2.5 minus 2 to the 1.5, okay? Because 2 divided by 5, 5 divided by 2 is 2 remainder 1, 3 divided by 2 is 1 remainder 1, all right? Now what we're going to do is we're going to separate the powers in the following fashion. I'm going to have 2 squared times 2 to the 1/2. I'm separating the integer from the fraction. Remember, this is a proper fraction, that's what we want. And then 2 to the 1 times 2 to the 1/2. Okay? Now, notice what I'm going to do here. I'm going to write this in radical form. This is going to be 2 squared, 2 to the 1/2, using the nth root property of exponents, is the square root of 2. Okay? Minus 2 to the, this 2 to the 1/2 is also square root of 2. All right? Okay, so 2 squared is going to be 4. 4 root 2 minus 2 root 2. All right, what on earth is this going to be? It's just like 4x minus 2x. Right? What is 4x minus 2x? If you have 4 x's and you take out 2 x's, you're simply left with 2 x's, right? You just subtract the coefficient of the variable. That's exactly the same procedure you apply here. 4 root 2 minus 2 root 2 is 2 root 2. Okay? So there goes your answer. But wait, all the answers are expressed as rational exponents. So we need to convert this back to rational exponents. So we're going to have 2, this has no power, 2 to the 1/2, 2 to the 1. And writing radical 2 in exponential form using the reverse of the nth root property of exponents, we're going to have 2 to the 1/2. Okay? Now that we're multiplying, exponents, we're going to use the product property of exponents, which involves adding the powers. So whenever you multiply an exponent, you add the powers. So you have 2 to the 1 plus 1/2. So what is 1 plus 1/2? 1 plus 1/2 is, we can write this as a fraction. 1 over 1 times it by 2 top and bottom. So we have 2 to the 2 over 2 plus 1 over 2. What I just did is I found the LCD of this fraction right here. So times this by 2 and times that by 2 top and bottom. So you have this, and then your final answer is going to be 2 to the 3/2. Okay? 2 to the 3/2. So your final answer is option letter C. All right, so they have a 2 to the 3 halves. That's one way of doing it. Let me show you, actually, let me show you another way of doing this. So let me start from here. So let's say we're on this at this step right here. Okay, so we converted the fraction into mixed numbers, and then we separated them. Check this out. If I have 2 squared, this is another way you can do it, times 2 to the 1 half minus 2 times 2 to the 1 half. Notice that 2 to the 1 half are common to these two terms. So what I can do is I can factor it out. So let me draw a line here. This is another way of doing this. Whichever method you like, you can always use, okay? So I'll just factor it out. If I factor it out, I'll have 2 to the 1 half on the outside, and I'll be left with 2 squared minus 2. All right, and then I have 2 to the 1 half. 2 squared, well, this is the one right here, minus 2, we just can write it as 4 minus 2. What's 4 minus 2? 4 minus 2 is 2, right? So we have 2 to the 1 half times 2, right? Since there's no power, we can put a 1 using the product property of exponents, which tells you that anytime you're multiplying exponents of the same base, you add the powers. This becomes 2 to the 1 half plus 1, like we did over here, 2 to the 3 over 2, and that's your final answer. Okay, so that's another way of doing it. All right, now let's move on to question number 2. We're asked to solve this equation for rational equation for x. So we have 1 over x plus 1 over a equals 1 over b. All right, so first thing we have to do, let's combine the left side here into one fraction. So to do that, we need to find the LCD. What is the LCD of x and a? The LCD of x and a is ax, right? X goes here a times, a goes here x times, all right? So we need to make the denominator is ax. To do that, we need to multiply the top and bottom by the appropriate terms. So this has an x and needs an a, so I'll multiply top and bottom by a. This has an a, needs an x, so I'll multiply top and bottom by x, okay? You can't just change the denominator. You have to multiply top and bottom so you don't change the problem. All right, so we're going to have a over ax plus x over ax equals b, 1 over b. Now that we have the same denominators on the left side, write it as a common denominator, a plus x equals 1 over b. Now, I can get rid of the denominator by cross-multiplying by cross-multiplying. To cross-multiply, the bottom on the left goes to get multiplied by the top right, and then bottom on the right goes multiplied by the top left. Okay, that's how you cross-multiply. So we're going to have a plus x multiplied by the denominator on the right, b, equals 1 times the denominator on the left, ax. Okay? Now, this procedure helps you get rid of the denominators, okay? So we can get x isolated without any problems. All right, so what I'm going to do next is distribute this b to these two terms. So I'm going to have ab plus bx equals ax. All right, so I want to get x isolated, so I have to put all the terms with x's on one side, so I can get x isolated by factorization, and then divide the coefficient to get x by itself, okay? So this term needs to go to the right. So how do I move it across the inequality without changing the problem? Well, since this is a plus bx, I'll do the opposite, which is minus bx from both sides, okay? So I'm going to have ab equals ax minus bx. Now on the right side, x is common, so I can factor that out. So I'll have ab equals x times a minus b. Now how do I get x isolated finally? I just divide both sides by a minus b. Divide by a minus b, divide by a minus b, and then I'm going to have x equals ab over a minus b. Okay? And that answer matches option letter E. Yeah, there you have it. Now let's move on to question number 3. So we are asked to solve this. It says if 3x squared minus 2x plus 7 equals 0, then what is x minus 1/3 square. All right, so let's see, how can we do this? Well, this is a quadratic equation, right? So let's try and see if I can factor this first. So I have 3x squared minus 2x plus 7. If I can get x by itself, then I want to do x minus 1/3 and then square it, okay? So I want to try and factor this first. If I can factor it, that'll be great. If I can't, then I have to resort to another method. So I'm going to use the AC method. Um, so AC goes on top, which is 21, and then B goes on the bottom, which is -2. What two numbers multiply to give you 21 and add to give you 2? Let's see. 21. What times will it give you 21? 1 times 21. This combination gives me 20 or 20. That doesn't work. The next one is 3 times 7. This combination gives me 4 or 10. That doesn't work. I need 2. Oh, well, these are all the factors of 21, right? So we're done. So this is a prime quadratic, so I can solve it by factorization. So I have to resort to what always works, which is a quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Okay. If I get x by itself, I can see with this expression, I can hopefully find out what x minus 1/3 square is. Okay. All right, let's do it. So what I need is a. A is 3, because that's a right there. What is b? -2, right? And then c is 7. Now you have to be careful when determining ABC. You have to make sure that this is in standard form. Okay. So what is standard form of a quadratic? The powers have to be in descending order. Power 2. The degrees have to be in descending order. Degree 2, 1, 0. And it must be equal to 0. Okay? So all the terms on one side equal to 0. If you're missing any degree term, you can just use a placeholder, okay, or fill a variable. All right, so no terms are missing here, so we have A, B, and C. So we're going to plug this into the quadratic formula. So we're going to have x equals -b, which is minus -2. Please be careful with the signs, okay? Plus or minus the square root of b squared, -2 squared, minus 4ac over 2a. over 2a, which is 2 times 3. Okay? All right. Now let's simplify further. We're going to have 2 plus or minus the square root of -2 squared is 4. 4 times 3 is 12. 12 times 7 is 84. Minus 84 over 6. Okay. All right. Simplifying further, we're going to have x, this equals 2 plus or minus the square root of -80 over 6. Well, let's just do it together first. Number 6. Okay, so let's reduce -80. So what does the square root of -80 reduce into? So let's break this down. -80. Since you have a square root under the radical, it comes out as an I, because remember I is square root of -1. You can take out a 2 here. 2 goes into 80 40 times. 2 goes into 40 20 times. 2 goes into 20 10 times. 2 goes into 10 5 times. Okay? So remember, any factor that repeats can break out as 1 because you're taking the square root. So 2 repeated factors come out as just 1. And then the square root of 2 times 2 is just 2. So these two 2's come out. So this basically becomes 4i rad 5 because 5 was by itself. It didn't have another partner to break out of the radical with. Okay? So this basically becomes 2 plus or minus 4i root 5. Let's put it over 6 over 6. Notice I separated the fractions. Okay? Alright, so let's reduce this and that will tell us what x is. So this equals 1 over 3 plus minus 4. Wait a minute. The 4 is, and the 6 can be reduced, right? We can do that by, so what I did here is I divided by 2 top and bottom. And this one I can divide the 4 by 2 because the GCF of 4 and 6 is 2. So divide the 4 and the 6 by 2. So that becomes 2I right 5 over 3. Okay? Alright, so looks like it's going to be easy for us to find out what x minus 1/3 is. Well, why did I say that? Check this out. We have x equals 1/3 plus or minus 2I root 5 over 3. So if I want to do x minus 1/3, how do I get x minus 1/3? I just minus 1/3 from here to get x minus 1/3, right? And then I'll square it. So you just minus 1/3 from x from this side and minus 1/3 from this side. And on the left side, you're going to have x minus 1/3. Notice what happens on the right side. These two cancel out. Voila. How nice. Plus or minus 2I root 5 over 3. So we're asked to square this to find the square, right? So what I'm going to do is I'm going to square the left side and square the right side. Okay. So that's going to yield x minus 1/3 on the right square. Now, what is plus or minus square? What is plus or minus square? If you square plus, you get plus. If you square minus, you get plus. So plus or minus square is just plus, right? So this plus or minus goes away. When I square 2, I'll get 4. So you notice we're going to square everything one by one by one, okay? So I'm going to square the plus or minus, I'm going to square the 2, I'm going to square the I, and I'm going to square the root 5, okay? Alright, when I square 2, I get 4. When I square, what is I square? I square equals -1. Remember, I is the square root of -1. So when you square both sides, you get I square equals -1, okay? So when I square I, I'm going to get -1. When I square root 5, the square root and the root cancel out to 5. And then the denominator, when I square 3, I get 9. Okay? So what I did just confuse you. Sorry about that. But what I meant is like I'm doing plus or minus square times 2 square times I square times root 5 square. Okay, using the product of powers, the power of a product property of exponents requires you to distribute the power to the product to each independent term that you're multiplying by, okay? And then also in the denominator, that power also has to go down there because of the power of quotient, 3 squared 2. So that's what I just did over here. Comes out nicely, doesn't it? Anyway, let's simplify that. That becomes 4 times -1 is -1 times 5 is -20 over 9. Okay? So x minus 1/3 square is -20 over 9. So your answer is option letter E. Alright, moving right along. Question 4, it says the graph of which equation is a straight line parallel to the graph y equals 2x. Now notice all these formulations right here are standard. Okay? And then this is slope intercept. Now there is an easy way to find out the slope of an equation if it's in standard or slope intercept form. If it is a slope intercept form y equals mx plus b, the slope m is simply m. And if it's an ax plus by equals c form, also known as the standard form, the slope is simply -a over b. Okay? So you can transform all these to standard to slope intercept form and find m easily, or you can just use this trick. This saves you a lot of time. Okay? So for the problem we have, the equation we're given y equals 2x, it's obvious to see that m, the slope is 2 because there's a coefficient of x. Okay, so that's what m is. B is 0 here. So the question is, which of these have a slope of 2? Alright, let's exhaust possibilities. Starting with A. A, we have 4x minus y equals 4. In this case, A is 4, B is -1, so the slope is, remember, it's -a over b. Let me write it here again so we don't forget. -a over b, which is -4 over -1, which is just 4. Is 4 equal -2? No, that's wrong. Alright, option B. 2x minus 2y equals 2. M is negative a over b. So that's going to be negative 2 over negative 2. Negative 2 over negative 2 is positive 1. Is positive 1 equals 2? Absolutely not. Wrong. All right, let's keep on going. C, we have 2x minus y over equals 4. M is negative a over b, as we already know. So that's going to be negative 2 over negative 1, which is positive 2. Is positive 2 equals positive 2? Absolutely. The correct option is C. All right? So there you have it. But if you forget this formula negative a over b, you can always get y by itself, and the coefficient of x will be your slope, and that will work. In this case, you just have y equals 2x plus 4, and then you just have that m is 2, and that matches also. All right? So this is just a neat trick for standard form. Remember, this is only for standard form. All right, moving right along. It says an equation of a line that contains the origin and the point 1, 2 is. So we have two conditions, the origin and the point 1, 2. So what on earth is the origin? The origin is where the x and y intersect, which is the coordinate 0, 0. Okay? And we're also given a point 1, 2. All right? So this is the x coordinate, this is the y coordinate. So which of these equations satisfy both of these conditions? You must satisfy both in order for the line to contain these 2 points, okay? All right, so let's test. We're going to exhaust possibilities here. Y equals 2x. If I plug in 0 for x and 0 for y, do I end up with a true or false statement? That's the question. All right, so the question is 0 equals 2 times 0? Is 0 equals 0? Absolutely. Okay, so passes the first test. The second test is 1, 2. Is 2 for y equals 2 times 1 for x? All right, is 2 equal to 2? Checks out, so that works perfectly. So the answer is option letter A. Okay? All right, if you look at option B, it passes it passes the first test, 0, 0, but it fails the second test because when I have two here, I mean 1 here, and I double that, it becomes 4 equals 1, which is false. Okay? So the only option that works is option letter A. All right? So there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here. You can also support the production of videos such as this by commenting or liking this video if you liked it. More videos coming from Mathgotserved.com. Thanks again and have a wonderful day.